Okay, you guys. So you are now moving on to the second part of this unit that deals with equilibrium. We're going to focus on chemical equilibrium, but we're going to try to get you to think about this. We've really been dealing with equilibrium in other scenarios already, but our focus will be chemical equilibrium. So if you could look in your note packet, you want to turn to page 12 of your note packet. We're only going to do the top half of these notes today, and then we'll get going from there with our next class. And just beginning with the definition of chemical equilibrium. So we would define this as two opposing chemical reactions that occur simultaneously at the same rate. So we're going to focus, like I said, on chemical equilibrium. But, equilibrium is just two opposing anythings happening at the same rate. So if we start real simple and you look at this graphic, you guys have a little bit of a different picture in your notes, and you could add some drawings to it to kind of mimic this. But if we had a bucket with holes in it and we're filling that bucket, the rate at which it's filled is equal to the rate at which it flows out as well, as long as we're not overflowing out of the top of it, right? So two opposing forces, filling in, flowing out, those are at equilibrium. The rate at which that bucket is filled, once we hit like all the holes in this poor little bucket, is going to equal the rate at which the water goes out. So that's equilibrium. That's not chemical equilibrium, but that is equilibrium. We could also talk about equilibrium in the sense of saturated solution. So remember, solution is going to show us it's saturated, or how do we know it is saturated if we're not massing and measuring temperature? We're going to put a whole bunch of that solute. So let's say that we put sugar in there, we put tons of sugar in some amount of water, enough that there's crystals that are left over at the bottom of that beaker that we're looking at. We're not messing with temperature, but we know the solution above it is saturated. Once we get to that point where I have stirred and stirred and stirred, I haven't changed the temperature, and I can't get any more of those salt or sugar crystals to dissolve, not going to change temperature to do it, but at anything else that we've got it all to dissolve that we still have a little bit of sugar left. So this is the crystal that's left. Now, at the rate that some of those solute particles are escaping and turning, and this looks like it's more like salt instead of sugar, okay, which is fine. So at the rate at some of those solute particles are dissolution, going into dissolving, so we have these arrows going up, is equal to the rate that some of these ions that were dissolving and already dissolved are going to recrystallize. Now, I don't like how in this graphic they use the language of precipitant. I would call that crystallization. It didn't precipitate, it crystallized. So if you're writing this out, I would change this word right here to crystallization. The rate of dissolution equals the rate of crystallization. Okay, so that solution is in equilibrium. So we could talk about the stuff that you guys just did a quiz on, making solutions. Once we hit certain temperature, we've stirred it, we got as much as we could get in there to dissolve, and we have that little bit of crystal that's left over at the bottom that we just can't get to dissolve because the solution's saturated. The rate at which ions or sugar, could be covalent compounds, are going into dissolution equals the rate at which some of those are going back into crystallization. So we can think of equilibrium, water in a bucket. We can think of equilibrium with solutions. What we're going to do, and we'll start it tomorrow live in class, is we're going to learn, well, can this happen with chemical reactions also? And it can. And then industry takes advantage of that too. So just get this notes going, get your brain wrapped around equilibrium, and then we'll get you started with our next class with this. Okay? Thank you.